Hello. Hopefully through this video I can show how inexpensively you can monitor a small farm, an orchard, or even a garden using ESP microcontrollers with built-in Wi-Fi and LoRa radio. LoRa stands for long range. Here you can see my gateway mocked up on my desktop with a Heltec ESP32 board. It has built-in LoRa radio and Wi-Fi capability. It's also got a built-in OLED display on the controller, which I'm not using. It just takes up too much power. I don't need it for this application. And it's all powered off the battery shown next to the board there. LoRa radio on these boards have a distance of approximately 6 miles with a good directional antenna. You could even go further and also transmit over different terrains, utilizing what's called node hopping. That's taking a signal and skipping it from node to node until it reaches its destination. In the LoRa radio, I'm using Radiohead, what's called Radiohead protocol, and that allows me to even encrypt the packets that are being sent from the gateway to and from the sensor nodes. I'm not doing it in this particular program, but I do have that capability for security. One reason I was able to do this project was because of the ESP32's dual core processor. One processor is for the LoRa radio. I'm receiving and transmitting data to and from 3 remote sensor nodes. The second processor is also being used for broadcasting over Wi-Fi through Modbus TCP protocol to my SCADA program that resides on my server. Here you can see one of my sensor nodes that's mocked up on my desktop. This is my East Orchard sensor node. To the right there you can see the ESP32 board with the LoRa radio antenna coming off the front of it. I've currently got this powered off my laptop. But on the same board you can see sticking up is the voltage divider that's bringing in, when I do have it powered with battery, it's bringing in my battery voltage and giving me indication of what that life is on the battery, and transmitting that to my SCADA as well. I've got 3 outputs going to these 3 latching relays. These are primary voltage is 5 volt, and I'm latching a 10 amp relay on the secondary side of that, normally open, normally closed, and it's latching these 3 contactors that are rated for 485 horsepower. The coils on these contactors are 24 volt AC. I've got a step down transformer as you can see at the top. The cylindrical thing in the middle is my SHT20 sensor. It's giving me humidity and temperature. Here you can see another sensor node. This is my northwest sensor node I've got mocked up in my backyard. It's essentially the same as the east sensor node. You can see the latching relays, battery, and SHT20 sensor, along with the ESP board. I'll show you the values coming off of this in my SCADA interface. This is my SCADA program. SCADA stands for Supervisory Control and Data Acquisition. This program resides on my local computer. I decided to use a SCADA program instead of a cloud monitoring application. I'm not paying every month for the number of variables monitored or the frequency in which I want to pull my sensor nodes that I'd be doing with a cloud solution. The SCADA program, which is from InduSoft, does have a mobile access routine. I don't have that programmed into this application. That would allow me to monitor the same data controls shown here over the internet to a website, phones, tablets, or other remote devices, and even send out emails on any given event or alarm. Here you can see I'm monitoring 3 orchards on this fictitious farm called Holland Orchards. I've got 3 faceplates that correspond to sensor nodes that are out in the field. I've shown you my east orchard. It's mocked up on my desktop, as well as my west orchard is also mocked up on my desktop. And the northwest I've shown that's sitting out in my backyard there. So these are actual values that are coming in. So I'm monitoring for this particular application, I'm monitoring for frost. And you can see I'm bringing in 68 degrees with a 46% relative humidity. And I've got a estimate here. This is a calculation that's in that I wrote in the SCADA program to give me a dew point temperature. This is 2 or 3 degrees one way or the other here. This is just a rough estimate, but it's saying if this temperature comes down to 44 degrees at this relative humidity, dew will fall onto the vegetation. Dew is where the atmosphere can no longer hold moisture, and it falls to the earth as droplets onto vegetation, and could become frost if it goes to freezing. I'm also bringing wind speed in and wind direction. I don't have anemometers hooked up on my sensor nodes at this time, so each sensor node, it's giving me and transmitting a random number that emulates the wind speed and wind direction. So these are actual values that are being transmitted from each sensor node. And then down below here I have a 2-position selector switch that corresponds to these 3 push buttons. And right now I'm in manual mode, so I can turn my east fan, my irrigation, or my auxiliary relay on manually. I have icons that are telling me what state those contactors are in the field. These are signals coming off the auxiliary contacts on those contactors. So right now you can see everything's unlatched. And the way I'm transmitting these control commands is bits in a byte. So I have 1, 2, and 4. So if all 3 of these are on, the number in the byte sent is 7. If this is on, it's 1. If this is only on, it's 2. So if 2 and this are on, it's 6. And if this and this are on, it's 3. So let me show you. Over here, this is my gateway transmissions coming and going from my gateway. So if I turn this on, you should be able to see it in my gateway, and there it is. I sent that 1 value to the sensor node, and you just heard that latch on that contactor from that sensor node. So I should get if I start the scrolling here again, I have these on a loop. I'm transmitting east, west, and northwest, and it's sending out a number to each sensor node. And the sensor node, if the sensor node's not busy, it'll recognize its number and take the control commands and parse the numbers and send them out as outputs, and then also send me back the values from the sensor. So you can see here we have a confirmation of 1. It sent me back a confirmation stating that that contactor is latched, and you can see it here. So if I go ahead and hit all 3 of these, we should see 7. And there we have it. We have 7. I've sent the value 7. So these are kind of catch as catch can. The sensor nodes are not frequency independent. It just sends it out, and if that sensor node picks up that number at the time, then it responds accordingly. We're West Orchard, Northwest Orchard. And we're waiting for the East Orchard. And we see that the gateway sent it out successfully. Just waiting for an acknowledgement back from the sensor node. The sensor node has not picked it up as yet. Obviously, I'm sending it out every minute or so. You wouldn't do this in a real live application. You might send it out, once an hour, or once every couple hours. But I'm just doing this for demo purposes. I don't want to wait an hour to get a value back. And there you heard all 3 of those contactors latch, and we got a confirmation that they indeed are latched. So if I go ahead and turn these off, we should decrement those values, and you can see it going down here, 4, and we're at 0. So now all we're waiting for is the sensor node to pick up that transmission. You can see it's 0 here. We're getting west control. See, these sensor nodes have not acknowledged the transmission from the gateways yet either. So there you hear the contactors unlatched, and we get a confirmation back as 0, so those go to unlatched. If I come in here and set this to auto, you can see I have 3 separate set points for each control. I may want the fan to come on at a certain temperature. If it gets any colder, have the irrigation come on, and then yet at another temperature have the auxiliary relay come on. So right now I'm in between 67. I haven't met any of these set points. So if I come in here and hit auto set, and let's make this lower than 67, so let's make it say 12, I should get an output. And there you see I sent a value, a control value to my east sensor node to turn the fan on, and I have an alarm set down here as well. And if I come in here, if I set this and make this higher than 67, say 89, I should get a 3 value. And there you see it, and also set another alarm. Now, to see it visually, this is an overview of the fictitious orchards, and I don't have confirmation yet. There you heard the fan and irrigation come on, and they just turned on. You see the fan starting to move there, and the valves are open. And if I come in here, these are alarm history and trending, and you can see at 2:33 I had the alarm came on for both the fan and the irrigation. And this is off my SQL database, and you can see I'm trending here. See the wind speed has changed. So I'm trending temperature, humidity, battery, and wind speed. And currently it's 67 temperature. Wind speed is 8 miles an hour. So I close this. And if I open up my SQL database and show top 1000, this is my alarm history. And come down here, you can see at 2:33 I had a fan and irrigation alarm. And then if I open up this, my trending, top 1000. Again, you can see at 2:47, I trended these temperatures to my database: wind speed, battery life, humidity. And that's all the time I've got now. I may do a part 2 with the code, but hopefully I've given somebody an idea on how to use the ESP32's. And until next time, goodbye.